Hey everyone, welcome to the 1.14 ONNX Runtime Release Review. I'm joined with Faith here, and she is going to give us an awesome overview of the features that were included in this release. Thanks for being here.
Great, thanks, Cassie. So we just released ONNX Runtime 1.14. This is our first release since our last November, and includes a bunch of new features and improvements and some new things to highlight. So ONNX 1.13 released with opposite 18 during this period. So we've added the support for opposite 18 operators as well in ONNX Runtime. We've also made a few changes to the thread pools to enable better performance and more flexibility for setting thread affinity and such. So those details are available as well in our documentation. We've also added a new custom operator API to improve the robustness of ability to use custom operators for different use cases. So here we have some details and example, but basically you're now able to wrap an entire model that can be inferenced with an external API or runtime using the ONNX Runtime custom operator interface. We also done a bit of refactoring to the execution provider interface as well. So this provides better GPU utilization and memory efficiency by allowing more flexible options on setting the GPU memory and GPU streams. So hopefully future the execution provider developers are able to use this to customize the stream implementation. And finally, in the general section, we have added a new Rust API for ORT. So this is not part of the release branch, but it is now available to build in main. So we're looking for people to try that out and give us feedback before we make that as part of a fully supported API. For performance wise, we continue working on different optimization techniques and updating the quantization support. So now we have support for AMX on Sapphire Rapid processors. And we also have a bunch of improvements that we've made to the CUDA execution provider for GPU. So this includes a lot of high focus on the firmware models, but as well as the stable diffusion model performance.
Thanks. And I also understand that for the stable diffusion improvements, we made big improvements for both running them within the Hugging Face pipeline that they've implemented as part of their diffusers library, as well if you're just running ONNX Runtime. So it's nice to see that we are staying up to date, supporting these state-of-the-art models and making sure that people can get the performance they need in order to deploy their solutions.
For execution providers, we have some updates to the TensorRT and OpenVINO EPs to keep up with their latest versions, as well as DirectML EP with the DML 1.10.1 support. We also have the RockM EP that is now supports 5.4 and is considered GA ready for broad usage. We're also introducing the Azure EP, which is a cloud-based EP that we'll get into more detail with and have a demo. But basically, this supports using Azure ML hosted models for hybrid inferencing that runs both on device and in the cloud. On the for ORT Mobile, we've added more improvements for pre and post processing, and we found that's one of the challenges that many customers have when it comes to running models on mobile devices. So we've actually used ONNX Runtime Extensions, which includes custom implementations of pre and post processing, and incorporated that into a package that is available to use with the ORT Mobile. And we'll talk a little bit more about that in detail. We've also continued to improve on XNN Pack support. So we've added more operators included in the iOS build. And then finally, for ORT Web, we've also incorporated ONNX Runtime Extensions for some common NLP-focused tasks. We also have some improved utility functions to make this better user experience. We have a few updates on the ORT training as well. So we have some performance optimizations and bug fixes for some Hugging Face models, as well as stable diffusion model optimizations as well. So that's a summary overview of what we have in this release. So yep, thank you, Cassie.
Well, it's time to jump in and talk about some of these features that we heard about in the overview. And the first one that we are going to talk about is the Azure EP, which is a really cool new feature. And Jeff has been working on it. Jeff, why don't you introduce yourself and thank you for joining today.
So hi, Jeff Mendenhall. Thank you for welcoming me, Cassie. I'm a program manager on the ONNX Runtime team, really focused on hybrid and edge scenarios and what we can do with that going forward.
Can you tell us a little bit more about why somebody would use it and what it is?
Absolutely. So it's really our first entry into the hybrid world enablement, so that a developer doesn't have to worry about, yeah, I've got to segment out or have two different paths of my code. We're providing a single API, so I can, as a developer, can say, hey, for this scenario, I want to go to the cloud, or for this one, I want to go on the client and at runtime. So you don't have to decide before. So this allows these kinds of scenarios, such as, hey, if I have a very large, super accurate model in the cloud, like a large language model, object recognition, whatever that happens to be, I can use that in the cloud. But I can also say, hey, there's times where either I need super fast latency, or maybe my device is not connected or has horrible bandwidth, and I want to do it on the client regardless. And so we can allow you to say, hey, depending on whatever happens to be happening on device or in situation, do this. It also allows for one other great scenario, which is I can have a gating model that says, hey, based on what the input is or what I'm currently seeing, would it be better to go to the cloud if
Right.
it's available, or would it be better, or I'll be accurate and enough to be on the client and thus save all the latency and cost and be that much more responsive. So those are some of the two key areas where we see developers really being able to take advantage of this.
That's huge. And that is something I think when with ML ops in general in the AI space, it's a very hot topic and it's honestly it's hard. There's so many different ways, things to think about when you're configuring your hardware for cloud APIs or for running locally. How do I leverage, in the different languages? And obviously ONNX Runtime supports multiple languages. So you have that benefit for doing the edge side. And then being able to make a small change to switch to a cloud model that you've now optimized and are using there, that's extremely powerful.
Absolutely. Yeah. It's really what we see as sort of the first step on kind of where we're going to go further and further with hybrid and give more and more capabilities, but we'll still do it again through one API for the developer so that it's make it as easy as possible. And that's sort of our first principle as we move through this.
So we talked about a lot of capabilities here. What do you find the most exciting about this feature?
I really think the most exciting part is going to see what our developer community comes back with as they use this, and what they say, hey, these are the interesting things we're able to enable. And better yet, hey, here's some other ideas we'd love to see in Azure and what we think that would also allow us to enable. Again, it's just the first step into the hybrid world between client and cloud. And I'm really interested to see both, what we can enable together on this.
Love it. I think it's really interesting too, just to think about the different like dynamics and like deployment kind of architectures that people are doing now. And I feel like this is more of an emerging one where people are starting to realize that they can run, distilled versions of the model on the edge and save cost and latency and all of those kind of those all those benefits for running the model on device. Right. And so they're starting to even like think about this as a deployment structure. And then when you do that, or starting to think about it as a deployment architecture. And then when you start to actually implement that, all these new kind of problems come in. And I think that this EP really just solves them for you before you even kind of like run into them.
Yeah, absolutely. It really gives the user experience back into the hands of the app developer to decide at runtime things you wouldn't necessarily know when you're compiling the app. So you don't know whether I'm going to have, as a user, going to have connectivity or not, or whatever the other variables I want to look at. But I can decide that and I can update that without having to worry about updating even my models. That's just application logic. I choose which path I want to go when, based on what I learned about how my user uses my app too. So that's what I mean. It just gives you so much more capability and power in the hands of the application developer.
Totally. And I didn't even think about that. If you lose internet or your device doesn't have, that connectivity in that moment, your app will still work.
Correct. Yeah, it just opens up so much more.
Cool. Well, thank you so much for joining us. We are now going to look at some demos on how to use this new feature. Now that we've learned a little bit about this new feature, we actually have the engineer that worked on it here to talk with us. Thank you so much for being here. Why don't you tell us a little bit about yourself?
Morning, everyone. So my name is Randy Shuai. So I'm the one of the contributor to this ORT release 1.14. And within this release, we have delivered a few cool features, which I would like to demo to you today, which may assist you a lot in your daily job. Okay. So the first thing I would like to demo you is my endpoint that deployed on the Azure machine learning. As you can see from my screen that there are a few endpoints I already deployed there. So before each of these endpoints, there are models serving as a server side. And the user can utilize some client script to ping these endpoints to get results from the inference. Let me quickly open one of my endpoints. So here, so behind this endpoint, what I deployed there is a object detection model. From this screen, you can see the status of my deployment, which succeeded. And you can see the URL of this endpoint. So this is how roughly, generally how it looks like that when you deploy and manage your endpoints on Azure machine learning, right? So so before we're moving forward with any consumption tips of utilizing these endpoints, I would like to show you the Triton server that is we utilize to deploy the endpoints. So namely that each of these endpoints I deployed there, they are the Triton server, which is developed by NVIDIA. From this page, you can see that it's on GitHub, where the link will be attached. That is a server client suite developed by the Triton. For the server, it can host a bunch of models, and for the client, it can help ping the endpoints and get results. Azure for Azure service, it supports this Triton server deployment as a preview release, where the deployment tips are published in this link. As you can see, there's a wiki page about the deployment of this Triton server. It's still in preview release, but still with impressive performance and stability. Okay, let's go to the details about the deployment. If we visit this page and we select Python as a deployment language, you can see the detailed step about deployment. First, maybe you have to install a few required prerequisites. And the next, you may be asked to specify the subscription and the resource group that you're owning as Azure resources. And finally comes a core part where you have to specify which model you want to deploy there. Namely, you have to specify the model name, version, and location, right? And next comes the final part where you just create a client and do the deployment. So to give you an overall view of how this script looks like, let me pull up one of my scripts.
Quick question.
Mhm.
So you were
Sure.
able to take this, it's like an image, right? The Triton image, set that as your inference compute, and then use the Azure SDK to deploy an endpoint using that existing image, right? Am I understanding that right?
That's right. So like I said, I just copied the script from the website. So I just want to give you an overview of how it looks like in one piece. We install some packages, we configure our IDs, and we create the client, right? And we specify which model we want to deploy there with all kinds of information, and we do deployment. So there's one thing I would like to stress on here is that I would like to show you the model folder structure. Since we are deploying a Triton server, we have to follow the protocol where the Triton orders. Let me just highlight the folder here. As you can see from my screen, there's a folder called models. That is a path I specified here, where under the folder you can host all kinds of models. And in this folder, you can see there's a subfolder named like model 7, and that is my model name. And another subfolder that named like 2, that's my model version. And within this model version folder, you can see there's finally a model that's a model ONNX. Okay. And another big piece of configuration is that in the same folder of this model 2 folder, there's a configuration file that's called config pptxt. So for this Triton server to be deployed, you have to specify how the model looks like. Let me open the file. So this file describes how the model would accept as input and what will be the output. Since we have deployed object detection model, we can see that there's an image as input, and we have object detected as outputs, their location, their type, and their confidence. So you can find every piece of information about this configuration from the Triton link where I shared along with this video. So basically, this is the structure of this folder that I like to explain. So
yeah, that sounds important to make sure people can actually deploy the way they need to. They need to understand how the like folder structure is, so that Triton can actually find the model that you're trying to deploy. And it also allows you to version it and everything as well. So that's all handled within the project itself, with the project structure itself. If I have a model that's already saved in Azure, is there a way that I can use it from the model registry in Azure, or does it need to be packaged as part of my deployment?
Okay, I think that's a good question. That if you already have a model served on Azure, if it's Triton server, you can directly consume it. But if it is not of a Triton server type, you have to redeploy it as a Triton type, because for the preview release of ONNX Runtime Azure, we now only support the Triton server as our server side. So that is one of the limitations we will just remove maybe in next release. Yes.
Okay, that's good to know.
Let me go back there. So after this deployment is completed and you get our endpoint successfully deployed, the final part of this wiki page is the testing. As you can see, there's a big section of testing the endpoint, meaning that you can simply copy the script here and reconfigure a few parameters and test the endpoint end to end to see everything works as expected. So as you can see that I have a test py file where I copy the script from the website. Endpoint here, and a few other things just following the main part. And finally, I will trigger the endpoint by calling the Triton client. And if everything goes as expected, you can see the output to be printed on the screen, which can testify that, okay, everything works as well as expected. So that may be something you want to do before you really consume our Triton, our Azure email. So let's go back to the deployment script. So for this script to be totally complete, it costs maybe around 10 minutes. So for the demo, to save time, I will not just run the script here. So next, I'm going to move forward to just try to trigger that point to see what it comes, what our command of installation would be look like. So this is a test pipeline where we release our release candidate of this feature. That is ONNX Runtime Azure for 1.14, right? So what I'm going to do next is I will install this package into my local box. Okay, let me try install it.
So everything we did while that installs up to this point was set up our online endpoint. And now we're going to look at how we can use the ONNX Runtime Azure endpoint locally and work with that online endpoint, right? So all of that was just for our server-side model. And now we're going to look at our client-side model.
Yes, now we're going to look at what we need to do from the client, how we configure this feature and just ping the endpoint to get results.
Cool. I'm
going to show you another script since the installation is done. Let me go to the same folder and I'm going to open another script on my end. That is infer py. So as a name says, that is this is a short script where we can consume the feature. But before that, allow me to explain a few configurations to you. So as you can see, that it's a short script that we installed on ONNX Runtime, right? And we were going to do some configuration by this session option. We create a session option and we add a few entries here. As you can see that we have to specify the endpoint type. That is Triton. We only support as of now. And we have to specify the URL. That is the URL where I copied from my endpoint portal. And also we have to specify the model name, version, and we have to tell that if we want to everything happen verbosely, that we want to see the detailed login from the console, but it's optional. And okay, next we will load the model from this folder I showed before, right? And of course, we have to specify it is a Azure execution provider to consume the feature. Okay, now after the steps here, we should have this model loaded locally successfully. And next, we will create some inputs. And what comes next is also vital, that we have to create some run option. And we will tell the run option that if we want to use Azure feature or not. And we have to configure the authentication key. That is a key that you can spot from your endpoint portal. And finally, we do the inference and print the results. So if everything goes well, we should be able to see that, okay, there's a HTTPS call made from our client to the endpoint. And we can have the results printed out. Okay, any questions?
Yeah, I have a question. So I see that you have both a CPU execution provider and then the Azure execution provider. So it can
Mhm.
basically decide whether it's going to run locally or on your Azure endpoint. Where's
It
the best?
means that we can have the ability that both running locally and on Azure. Yes. And another answer to your question would be like this for an option. As you can see that we have this option that to specify whether we want to use Azure. If
Mhm.
we specify there to be one, the inference will utilize this Azure execution provider to send request to remote endpoint. But if you leave it as a zero, everything will happen locally, meaning that we will empower
Okay.
the user to just select between each run that whether he want to go locally or go to remote.
Okay, cool. So I could add some conditions in here and maybe have some static logic that decided whether I wanted to inference locally or on Azure
Exactly.
and partition that based on my needs for that
Yes.
model. And that's all I have
Yes.
to do. That is so cool.
It can be on per run basis. For next run, you may choose to go local, and for the run after, you may choose to go remote. That is totally up to the user.
Cool.
Okay, so
Yeah.
I'm going to run the script, see what happens. So for now, we're expecting that everything go remote because I'm enabling this use Azure configuration to be one. Okay, let me open my line. And all right, I'm going to run the py. Let's see what happens. Okay, now as you can see that we have a verbose printout on this that there's HTTPS call made from my local box and to the endpoint I configured. And as you can see that there's a valid output as output from the remote side. And the script just initiated a run that targeting the remote endpoint. Okay, to try out another option, I will just modify this script a little bit to put a zero there, meaning that for next one, I want everything to be happen on my local box. Let's see what happens. If I trigger this run again, now as you can see that there's no remote call being made. Everything happened just with local CPU provider. That's everything's getting configured and completed.
That's so cool. And there's so many use cases like that. Like you could say maybe you have like a lower performing model that runs
Yes.
and you want that to run, try it first locally. Maybe you don't get the confidence score you want. So you want to use your more accurate model in the cloud. You can even get like input from a user, like, did that answer your question for like a language model or something? And then if it didn't, try going to your cloud model, which needs more resources than running locally.
Exactly.
And you can partition out exactly how you want to run your model
Yes.
with a very small change in code. That is really cool.
Right. Also, it helps you to save some power from your edge device.
Yeah.
Yeah.
So could I also use like the CUDA execution provider locally as well? Like I could use any execution provider that is
Exactly.
supported on the device. Yeah.
Yes.
Cool.
Yes. Absolutely. So basically, this Azure feature that we are going to deliver with this coming release as a preview. So in the future, we are still planning to just to for better usage and for faster transfer of data. So everything is still ongoing.
Very cool. So like right now, like you said, they have to use the Triton inference scenario, but you said going forward, that's going to be updated and they'll be able to use, whatever deployment inference server that they want on Azure, right?
That's right. That's right. That's one of the plan that in the future we may support all kinds of deployment types from ML, meaning that users are free to just utilize what are already there available on ML. So there will be no need for redeploy.
And there's a lot of actually benefits for using the Triton server though as well. It comes preloaded with a lot of different configurations that you need for inference, for optimization.
Yes, exactly.
Yeah. So it's not really, I guess, like a negative in my opinion to have to use the Triton server because it is preloaded and then you can configure it, additionally with whatever packages you need for your deployment. So
that is correct. Yeah.
Yeah,
I think that's all for this ONNX Runtime Azure for the new release.
Next up, we are talking to Scott, he's been on actually every single, I think, release video we've done so far. So thank you for joining us again, Scott. And what are you going to be talking to us about today?
Thanks, Cassie. Today we'll talk about the new things we're releasing in the ONNX Runtime mobile world. And in particular, we've had a lot of focus on improving the pre and post processing story for mobile usage. Like historically, mobile app developers don't really know the world of tensors and all that kind of low level AI stuff.
Yep.
So it's a big barrier to adoption to, well, I've got my image, I want to run this model. I have no idea how I need to create this strange multi-dimensional piece of data to run the model with.
The other thing too about that is sometimes the languages just really aren't good at working with tensors. Like Python has a lot of really great numerics libraries and things that make working with tensors a lot easier. And you get into some of these other libraries that aren't necessarily used for like science as much, and it becomes a lot more difficult to do that pre and post processing that you need. So it's not even just the knowledge about the tensors; it's also just having the tooling, right?
Yeah, because mobile devices don't have Python. So you see these examples for here's how you run the model, and in pretty much every single one, the pre and post processing is done in Python. And it's like, well, now I have to translate that to one thing on Android, one thing on iOS. I don't have these Python libraries like Pillow for image resizing. Like, what do I do, and how do I do it right?
Exactly. So we want to make that easier, and this ONNX Runtime Extensions, that's what it's for, right?
So ONNX Runtime Extensions is essentially it's an add-on to ONNX Runtime that has a bunch of additional custom operators. And so what those can do is implement more domain-specific logic. So for example, in our image pre and post processing, we're adding a custom operator to decode an image like a JPEG or a PNG, and to encode an image from like RGB back to PNG or JPEG. So as an add-on to ONNX Runtime, we're a bit more flexible in what we can put there. And so we've added these custom ops, and we're going to add some mobile packages for Android and iOS, which will let you hook together ONNX Runtime and the extensions package. So you hook the two together, you take your model and you add some additional pre and post processing operators to it, hook together ONNX Runtime and ONNX Runtime's extensions, and then it can load the model and it will all run inside of ONNX Runtime. So that then changes it from, you still need to create a tensor, but for an image model, it will just be, give me the bytes from the original image. So no other steps required. And then the model will produce its output if it's something like, for example, super resolution, where the output is the upscaled image. We can also encode that back to a JPEG or a PNG. So you're going to get bytes for that back out. And so on Android and iOS, JPEGs and PNGs are supported very well natively. So then it's just, well, these bytes are an image. Now you can just go and display it.
That's great. It really simplifies the process for that pre and post processing that I know I have definitely worked on implementing in multiple languages for different samples and stuff that we have. So it's really nice to see progress in this space.
And it's also the bonus that, like, because it's inside the model and we're providing the implementation of that, you don't have to write code for Android and iOS separately. So all that cross-platform code to do that work also goes away because we take care of it all for you.
That is so cool. So I have this one extension that I can use now in all of the languages, and I don't have to re-implement it in any different way. That is super powerful. So what scenarios and platforms are supported?
Yeah, so starting off, we've focused on some image processing scenarios, like things like MobileNet. Pretty common steps there. Like you got to resize the image, you got to center it, you got to crop it, you got to convert it to floats, you got to normalize it to within a certain range. The super resolution, you might need to convert to a format called YCBCR. So in the image world, we have a bunch of, it's tooling like the Torch Vision transforms where you say, here are the pre-processing steps I want to perform. And so we have some scripts to update the model where you say, okay, I want like resize first, then I want to normalize to this range, etc. So you pick and choose your steps. There are predefined ones for some of the common steps, like, for example, PyTorch training for ImageNet-based trained models like MobileNet, etc., has a well-defined set of steps. So that's all predefined, but it's also very customizable and fairly simple. You just pick and choose the steps in the order. And then you point that at the model. It will go and insert all these things into the model and write out your updated model for you.
Let's take a look at this example of like a high level of how we could use extensions.
Yeah. So this is a complete end-to-end tutorial we have for a super resolution model that comes from PyTorch. So first step, we're going to grab the PyTorch model. it's a pre-trained model, which we're using in this example. So you'll see the torch code to create the model. We'll load the pre-trained weights there. Then we'll export to ONNX using torch.onnex.export. So that gives us the ONNX model with the PyTorch super resolution. Next step, we want to add our pre and post processing. So the choice here, output format could be PNG or JPEG. When we release the ONNX Runtime Extensions Python package, it's going to have this add pre and post processing tool within it. This has the predefined things for like MobileNet and super resolution, but it also has the individual steps so you can customize the pre or post processing to match the model. So with that, we're just going to point it at our model. It's going to read our model in, it's going to add all those pre and post processing steps, and it's going to write out the new model. And so the final step is to run it with super resolution. Want to see the results before and after. So this will run the original model with the input plus the new model. And you'll see, sorry, the original model doesn't do the pre and post processing. So we run the original, we run the update, and we display the two side by side. So that just shows the entire end to end, and you can see the results. One very important note, you'll want the ONNX Runtime 1.14 release. The reason for that is if you're resizing an image, the new offset for ONNX supports anti-aliasing, which is really important. Like most of the pre-processing image resizing done with Python will have anti-aliasing enabled. So you'll get a much better result if you're using that. And so, yeah, that's offset 18 with the latest ONNX Runtime release.
So that's important to note that so they have the right configuration set up. It's so cool how much this simplifies. And obviously we're looking at it in Python, but you could use this in other languages, like you said. And then I think that there are going to be some examples here as well that we want to share.
Yep. So basically, because we're releasing mobile packages as well for ONNX Runtime extensions for Android and iOS, we've also set up some example apps that are actually running that super resolution model produced by that end-to-end script. So this will give you an idea of just how simple it becomes when you just simply need to get your input image, put the bytes from that in a tensor, and run your model.
That saves so much time.
Yeah, and those aren't quite ready to go. We need to update it to the release packages when they come out in the next few days.
Great. Well, I think they'll be released by the time we release this video. But if not, come back and check. Yeah, we'll put all the links in the description as well as soon as everything's available. So if it's not right when this video is released, it will be very shortly after. So definitely check this stuff out. Try it out. It's really cool, really important work to help people be able to build solutions and deploy solutions.
Yeah, and so right now we're supporting some of the more common image uses. We'll expand that in the next release. What we're also going to start including is tokenizers for language-based models, for example, like BERT tokenizers, so that can also be handled by the model, which will mean that your mobile apps don't need to find a BERT tokenizer on Android and iOS and whatever other platform you're using.
That's awesome. Makes it so much easier. Cool. So was there anything else about the extensions or this particular release that you wanted to share?
Some other updates to the XNN Pack EP for ONNX Runtime Mobile. So this is good for floating point, like 32-bit float models on mobile platforms. So we've also included the XNN Pack EP in the iOS packages now. So now it's available by default in the ONNX Runtime Mobile's Android and iOS packages. We did some changes to improve the memory usage, and we also added support for some additional kernels. So MapMul and Gem are two of the big ones there. So that will mean a lot more models can be accelerated using the XNN Pack EP or execution provider.
Yeah, it's great to see us continuing to support more models and more complex architectures and making things easier for our developer community. And that's really what we're trying to do: get performance cross-platform and make things easier. So a lot of really great updates in this release that is following in line with a lot of those goals. It's great to see. Well, thank you so much for joining me, Scott, again. I'm sure we'll see you next release video. Talk about some more cool things that you've been working on. And yeah, thanks so much.
Cool. Thank you, Cassie.